So now that we can solve equations, let's see if we can plot some functions or some vector fields. Okay, so let's say we have, let's define a function. So f of x is, say, x squared plus 2. We want to plot this function. Plot f, and let's see what happens. Yeah, it works. That's our f of x. We want to provide some limit. So probably -3 to +3. Yeah, it works. -3 to +3, and that's pretty much it. Okay. You want to save this, diagram. Now the next question is, this is a scalar function, but sometimes we have, vector functions or vector fields, for example. So if we have such vector fields, then how can we plot them? So one example is electric field. If you know a little bit of electricity and magnetism, then probably you have heard the term electric field. So it's basically a vector that can change its direction and magnitude at any point in space. So the vector field is, expression is like this. Electric field at some point is Coulomb constant k, charge q, times r hat divided by r squared, or vector r divided by r cubed. So if we want to do this in LaTeX format, then it's probably something like this. Okay, so yeah, now it's like this. So electric field at point P is k times q times vector divided by vector's magnitude. So since k times q is just a constant, if we can plot vector divided by vector cube, r by r cube, then that's basically the shape of electric field. So what is r? R is just, x squared plus y squared in 2 dimension, and we have, square root, so power 1/2. That's our r, and we want to plot this vector field. So we have function plot vector field. Okay, we can also plot in 3D. So let's see 2D first. So plot vector field. So we need to provide x and y variables. So that means our x component will be x divided by r cubed, and y component will be y divided by r cubed. And what's the limit? X from -3 to +3, and y from -3 to +3. That's the region. So let's see. So magic, right? We have these vector fields like coming off of a single point, like from the origin. So if you want to change the color, so it should be in a quotation. So now we have in blue color. If we have some negative charge, what happens? You have an overall minus sign. So minus and minus. That means all the vectors are going inward. Okay. Now let's say we want to plot, in 3D, R3D. So then now we'll have this term. Let me copy it. But we'll have extra z squared, and let's say this is 3/2 because we need to like cube it anyway, and plot vector field 3D. So we need to provide, some 3D expression. So let me copy paste it here. I saved it earlier. So x is from -2 to +2, y is from -2 to +2, z is from -2 to +2, and this is our x, y, and z component of the vector in 3D. If we press Shift Enter, we'll see some diagram like this. So you can interact with it, As you can see, it's again something coming off of a single point, the origin of this system. Pretty nice, right? Okay. Okay, so that's how we can plot vector fields and plot simple functions. There are tutorials available on SageMath website, and you know, I'll have the link in the video description, installation tutorial and everything. Okay, so if you just like get stuck on something, you can just say plotting. Here you'll see how to plot things. Commands are there, three-dimensional plots, parametric plot, and everything.